Welcome to this explainer. Okay, picture this. It's a sweltering summer night. The AC is absolutely blasting, ceiling fans are spinning at max speed, maybe the fridge is working overtime just to keep your drinks cold, and then suddenly, click, total darkness. So, you're sitting there in the dark, and we're going to treat this scenario exactly like a mystery. Why did the power guy? You look around and, well, there are no flames. There's no visible short circuit, no obvious disaster. So who or what exactly killed the power? You're just left sweating in this dark, hot room. But here's the thing. What feels like a super frustrating, totally unprompted interruption is actually an invisible, highly engineered protective system hard at work. The technology behind that humble breaker box in your garage is stepping in, responding to a dangerous buildup of excessive current and heat that you couldn't even see. To understand this electrical crime scene, let's look at Section 1. The square of the current, how wires get dangerously hot. Basically, moving electrical charges transfer energy to a conductor's atoms, which naturally warms up your home's wires. And the physics here brilliantly illustrate the danger, because the heating rate grows roughly by the square of the current. Think of it kind of like a small crowd suddenly turning into a massive stadium-sized mob. Even a modest, seemingly harmless increase above your circuit's specific rating creates a massive, exponential spike in heat, especially anywhere you might have loose or resistive connections. So let's head over to the electrical panel for Section 2, inside the circuit breaker. Time to meet your electrical bodyguards. Inside most standard household breakers, you actually have dual protective mechanisms. On one side, we have thermal protection. This is your slow, patient bodyguard. Think of it as a slow, sweaty bouncer. It uses a bimetal strip made of metals that expand at different rates as sustained current heats them up, eventually bending until it physically releases the trip mechanism. On the other side, we have magnetic protection. This is the fast-acting bodyguard. It responds instantly to the massive current of a short circuit by creating a strong magnetic force that trips the breaker immediately, cutting off the energy before it causes a full-blown catastrophe. So why does this always seem to happen when we need the power the absolute most? That brings us to Section 3, Summer's invisible pressures. Why heat waves break the system. Summer just adds two very specific environmental and mechanical pressures that push these protective mechanisms to their absolute limits. First, your cooling equipment is running much longer. Second, it might be sharing a branch circuit with other heavy loads. But crucially, consider this third point. The ambient air surrounding the breaker box itself is already baking hot. And honestly, that's the secret ingredient for a sudden power drop. This leads us to a really critical engineering reality. Breakers must often be derated when the enclosure temperature is high. Remember that slow, patient thermal bodyguard we talked about, the bimetal strip? Well, because it's sitting in that hot summer air, it's already physically heated before the electricity even begins to flow. It's starting out much closer to its trip condition, giving your entire electrical system a vastly reduced margin of safety. But wait, there is another hidden culprit causing these summer blackouts. Section 4, the motor inrush spike, the heavy lifting of starting up. So, inrush current is a brief starting current drawn by a motor that is significantly larger than its normal running current. When your AC compressor kicks on, it takes this massive, greedy gulp of electricity just to get those heavy mechanical parts moving. It's exactly like pushing a stalled car. It takes a massive, exhausting effort to get it rolling, right? But it's way easier to keep it moving once it starts. A properly designed circuit handles this initial jolt completely fine under normal conditions. But when you combine that massive gulp of electricity with a circuit that is already heavily loaded and hot, it becomes a perfect storm. Throw in low voltage, repeated compressor starts, or aging equipment, and that initial surge easily crosses the breaker's time current limit. The bodyguard steps in and trips the system. Which takes us to a very crucial safety topic. Section 5, dangerous resets. Don't fire the bodyguard. Human error is often the absolute biggest danger here. I mean, we just want the power back on, but replacing a breaker with a higher rating allows existing wires to overheat. Upsizing a breaker without upgrading the wiring is essentially firing the bodyguard while the threat is still inside your house. The wire size, the insulation, connection quality, and ambient temperature all dictate what is safe. If you just slap a bigger breaker on smaller wires, you're literally allowing them to slowly cook inside your walls. You also really need to watch out for these danger signs. If your electrical panel smells hot, if you hear buzzing sounds, if you see discoloration, or if the breaker simply will not reset, the trip isn't just a summer nuisance anymore. It's a severe warning.
It could be an overloaded circuit, a failing motor, or a highly dangerous wiring fault. To properly investigate this, follow these exact steps for a safe response. Step 1, reduce or disconnect loads safely and only do so without approaching damaged equipment. Step 2, follow your panel manufacturer's specific instructions for resetting. And step 3, if it trips again, or you noticed literally any of those danger signs we just discussed, leave the circuit completely off and call a qualified electrician. Don't mess around with it. And that brings us to the final verdict of our hot summer night mystery. Section 6, the verdict. Failing safely by design. Here is your biggest takeaway for today. A healthy circuit carries its intended load, period. A new pattern of tripping is evidence to investigate. While summer heat absolutely reduces your margin of safety, you should never dismiss a new pattern of tripping as just, normal summer behavior. If it starts happening without any obvious added appliances, it is always evidence that needs to be taken seriously. The hot night doesn't magically make the electricity flowing into your home stronger. It just drastically increases the demand on your home while simultaneously squeezing that thermal safety net we talked about earlier. I actually really love this profound quote from our source material. What feels like an interruption is evidence that heat and current have reached a level the circuit should not continue carrying. Ultimately, the circuit breaker opens up because its entire sole purpose in life is to fail safely before the wiring inside your walls does. So, knowing that this tiny, unassuming, and honestly pretty cheap mechanical device just prevented a potential fire by doing exactly what it was engineered to do, I have to ask you this final question. Next time the power drops on a sweltering hot night, will you curse the breaker or will you thank it?